Good morning, everyone. My name is Corey Lanou, and I'm going to be your trainer today for this workshop that we're going to host. First, I'm going to start off with just some basic resources that I'm going to share with everyone so that we can get on the same page. First of all, where can this slide deck be found? So this slide deck is actually going to be hosted on learn.gopherguides.com. So you can click on that. And when you get there, you can enter the code free to go bootcamp. And this will allow everyone to see the exact same thing that I'm saying. You do need a GitHub account to sign up for this. So if that's a problem, let us know. But hopefully it shouldn't be too big a deal, because if you're doing Go and you don't have a GitHub account, that's kind of a problem within itself anyway. Okay, so that's our first resource that we want to share. The second thing that I do try to get people to do is get on the Gophers Slack. So this is a free Slack channel that is hosted for us. I'll put that in the Slack as well. A lot of you are probably on Gophers Slack already. If not, that is the link that I just pasted in there real quick to get a free email invite. And once you have that invite, you can go ahead and click on the next link that I gave you, which is actually the channel that we will be in today. And we will be probably doing most of our question and answer through there. So I do encourage you to get on the Slack. This is the same Slack that most of the community and actually Go core team experts actually hang out on as well. So this is a really good way to get involved with the community, ask questions even after the training. And you can feel free to always ask me questions or Mark Bates questions as well. At any given time on Slack, and we try to get back to people as much as we can. But if you're going to be in the Go community or doing Go code, it is very important that you get on the Gophers Slack. It's where I am all of the time. And then there's also a lot of Go meetups in the area. So if you're not in a local Go meetup, I highly encourage everyone to go out there and try to find one and start attending them. The Go community is fantastic. I encourage everyone to get involved. So go ahead and check out your Go meetups there. And then lastly, if you ever want to share any Go code, we'll cover this later too, there's what we call the Go Playground. And so you can see basically it's a really quick little sandbox where you can put Go code in and you can share it. We'll use this throughout the training as well. I also encourage everyone, if they have a question, and if you're not able to basically state it easily, a lot of times it's much easier to state it by actually coding up a quick example. So I encourage everyone to go ahead and use the playground to do that, and then share that, and then we can also share that back on the video. And answer any questions as we go through as well. So do not hesitate to be interactive. Do not hesitate to ask questions. So hopefully by now everyone has gotten a chance to kind of get on the Learn platform. Everyone's gotten a chance to start getting through the code. We're going to start just walking through installing Go. Some of you may already have Go installed. If you do, that's fine. But installing Go is actually pretty simple, which is pretty nice. So we're going to cover installation for Mac, Windows, and Linux in this one real quick. The easiest way and preferred way is actually just to go to the download page. So if you just go to golang.org DL, here's most of your installers. It's actually pretty straightforward. That's one of the easy ways to do it. If you are a brew user on Mac, it's as simple as brew update and then brew install Go. This is the method I use, but not everybody prefers that method. So if you're familiar with brew, I would go this way, and if that's what you're using, otherwise please go ahead and just download it. Go is one of the easiest languages to install. It takes just a couple minutes to download and install, and you're good to go. So go ahead and get that done if you haven't done that already. And then if you're using Linux, you can also use apt-get if you want. Sometimes there's an older version of that. I don't know if that's still a problem or not, but I know in the past it has been. So just be aware that if you do use apt-get on Linux, that you may be out of date. So just keep that in mind. And that's installing Go. So hopefully everyone will have that done before we get too far in here. One of the things about Go, though, that we always need to talk about is the Go path. And so basically, the Go path is where all the Go files are going to live on your system. And this is the source of a lot of confusion for people that are new to Go. And in Go 1.8, we try to get a little bit better. And basically, if you didn't set a Go path, that's okay. It's going to go ahead and try to just interpret and figure out where it thinks the Go path should be. But the one thing that is really important is, even though you don't have to set Go path in 1.8, you should really explicitly set it yet, because there's a lot of tooling out there and third-party tools that are going to look for your environment Go path and haven't figured out how to actually use the default Go path if it's not set. So you're going to find a little bit of headache. Sometimes you don't set that. I still explicitly set mine, hoping to get to a point where all the tooling catches up and we don't have to set that, but currently that's probably not the case. So just keep that in mind a little bit. So setting up the Go path is pretty easy. You can put it in your bash profile or the equivalent file. It's literally as simple as export, set the Go path in the variable. Windows can be a little bit trickier, as we all know, to set some of these. And so I provided a really nice link how to actually set up environment variables in Windows. So here's everything you need to know how to set up environment variables. And if you're familiar with Windows, probably not a very big deal, but you will have to go ahead and get that set up on Windows as well. And it's important to make sure that the path you set for your Go path matches your actual file system. So these two are not equivalent. As you can see, one is an uppercase G and one is not. So depending on the tooling and the platform you're on, just make sure that you get that set properly. And then finally, Go path is not Go root. Most people don't need to worry about Go root, and typically you shouldn't have to. Your system should already be set up, especially if you use the installer. But if you got any questions on it, you can look it up more. But for the most part, Go root shouldn't be something you have to worry about if you use the installer or brew install. But again, Go root is really where you're going to see all the actual Go installation. That's not your source code, so don't confuse the two. In general, not too many people talk about Go root anymore, so hopefully it's not going to be an issue. And then another really nice trick is to actually add the Go bin directory to your path. The reason why you do this is when you install Go tools or install your own binaries locally, they actually end up in the Go path bin directory. And if you add that to your path, then all of your tooling that you're creating for yourself is actually available pretty much anywhere on your system at that point. So this is something that most Go developers just kind of do reflexively. And so it really does help you out quite a bit, especially if you do a Go install from another package as well. That'll make that tool available on your system path. So definitely recommend doing that. And then if you look under the Go path is pretty straightforward. It has basically 3 directories in it. And so to kind of explain the breakdown of this, so bin is where all the compiled Go programs are going to be installed. We just talked about that a little bit. PKG is where the compiled packages are. You can pretty much ignore that directory. You shouldn't have to worry about that at all. That's basically just used by all the Go tooling for compiling and debugging and so on and so forth. And then the source directory is actually where all of your code is actually going to live. So underneath Go path/source is where you're going to want to put your code. And in the layout of that source directory, it's pretty common to use your GitHub username or so forth. So basically, it's a kind of a canonical layout. And so typically, a normal layout is going to be Go path/source, github.com/your username/project. Now, if you're not using GitHub, it's going to be a different domain, obviously. But just understand this is canonical. And if you use this type of layout when you set up your projects, this is going to make it really easy for the Go get tool. And it's going to make it really easy for other people to use your code as well. So then lastly, there's a system check I like to run. And basically, you can copy and paste this code to your local machine. So after you've installed Go, you can literally copy and paste this into a Go file. Just call it main.go, wherever you want. And it doesn't have to be in your source directory, believe it or not. But it should be, just so you rule out any other issues. You copy this, paste it, and you run it. And if this works, you'll get printed out success. If for any reason, if you run this and success is not printed, typically that means that your Go path is not set up properly. So that's going to be an issue. It's going to create a headache for you. So if you've done everything that we just talked about, this is going to run and say success. If not, let us know in the chat, and we'll try to work with you at the end of the session to get that working. But this is pretty important, and this pretty much is going to show whether or not you got it set up properly. A few optional steps. There's a lot of revision control systems that GoGet relies on. Most of you are going to be using GitHub, and it's not going to be an issue. But if you do have to do any GoGets from any other revision systems like Mercurial or Subversion or Bazaar, basically you want to make sure that all of those revision control systems are actually installed on your local machine for development. And so these are just steps to do that. So there are additional steps that you can do. They're certainly not necessary for what we're doing today, but just remember in the future this might be something you need to do. As far as editors, you can pretty much pick your favorite editor. There's a lot of them out there. Visual Studio Code, believe it or not, is really, really taken off. This has become just a fantastic editor for people. It's got built-in debugging support. It's got syntax highlighting, coverage. I mean, it's just kind of got like the whole kitchen sink and everything in there. So if you're looking for an editor and you haven't picked one yet, believe it or not, Visual Studio Code is a fantastic editor for Go. Highly recommend it for a lot of things. I actually use it for debugging, even though I'm a Vim user. Other than that, pretty much every editor has Go support at this point. So if you've already got a favorite editor, you probably have a Go plugin for it. So don't worry too much about that. But again, here's all the editors in there. And again, here's even more editors. If you want a full list of editors, you can go to the Go wiki right here. And as you can see, there are a lot of editors out there. So should not have a problem picking a favorite editor for what you're doing. So now let's get into a little bit of just why Go. And this isn't going to be technical so much as just kind of some background. So if you're wondering why you should even learn about Go, let's kind of talk about that a little bit. And we'll cover this fairly quickly, and then we'll get into some actual code examples. So first of all, let's talk about some companies using Go. You're probably going to recognize some of these names. You know, some small companies like Google, Facebook, Yahoo, Netflix, Uber, IBM, Square. If you're wondering who actually uses them, here's like a list of basically fairly confirmed users. As you can see, the list is pretty big. When I first did this presentation years and years ago, this list was a fraction of what it is today. And so you can see there are a lot of companies using Go at this point. I'm finding that pretty much any large corporation whatsoever at this point that does code is already using Go. Go is really hitting the enterprise. It is really taking off. So it's just a great time to learn Go because if you're working for any technological company at all, you're probably going to be using Go at some point. So the big reason is why Go. We have a lot of languages out there already, right? And you have to wonder, why did we have to have another language? And it feels like a big language war out there, and it feels like everybody's racing to the top to be the new cool language. And so why Go? So one of the answers is because we had to have an awesome mascot, right? I mean, are these Gophers not cool or what? So if you haven't been familiar with Go, you're going to find out the Gophers everywhere. You're going to see the Gopher in all the logos out there, and they are just crazy and zany and a lot of fun. But the real reason we needed Go is because Go was actually created to make software engineering easier. And it's really important to understand that when we talk about making engineering easier, we're not just talking about making it easier at scale, at the machine scale either. We're also making it easier at the human scale. And so what does that mean? So if we think about developers' basic day, right? We look at a compile test time, and we take compile times that are 65 minutes versus 5 minutes. Or people that compile and test once per day. They work on code 40 hours a week, 40 hours per day. The 40 hours per week employees spent compiling, or per year actually. And so that basically is an average of $100 an hour employee cost at $40,000 a year, right? So if you've got 20,000 employees and you start figuring out this math of how much faster this code compiles and how much less time you spend testing, running tests, that makes a big difference to big companies, right? Now, even at smaller companies, it's still pretty important. One of the things I find is because Go runs so fast, test coverage runs so fast, that you actually run the test and actually run the coverage. I've worked on different projects where the test takes so long, you pretty much have to go to launch, and that just means you're not going to run your tests as often, and that really makes development more difficult. So ease of use for testing and speed of testing and compiling, that is really a big deal. Do not downplay that whatsoever. So in the words of Andrew Duran, and if you don't know who he is, he's part of the Go core team. He's been there for a long time. He basically said software should be simple, but more than that, actually software can be simple. And what do we mean by simple? By simple, we really mean that it's small, it's readable, it's consistent, it's orthogonal, it's predictable, it's robust, and more importantly, it's actually useful by default. And for computing purposes, orthogonal means isolated or partitioned. So these are really some great statements, and they seem pretty straightforward, and they seem kind of obvious, but not all languages have this, and that's really important. And Go actually does prescribe to these, and they are very, very simple and very useful concepts. So that's kind of why Go. You're going to find a lot of the slides that I had in there were actually based on Andrew Duran's Railsbury presentation a long time ago. So just understand that I didn't make a lot of these slides up. They were based already on someone who wrote them, but this is all very good information. So actually now let's get into actually Go at a glance here, and let's actually start taking a look at the code and starting to understand a little bit about how Go lays out. So some of the language features to begin with in Go is it's compiled language. It's statically typed. It has a clean syntax. It has a simple type system. It has concurrency primitives. This is really cool. It basically means that concurrency are part of the primitives, just like integers. It has a very rich standard library. It's kind of a batteries included library. A lot of open source tools, a lot of great tools, and then testing and benchmarking right out of the box. So that's pretty important. And the Go command actually is kind of like the Swiss Army knife of tooling for you. So you get this Go command right away, and it does a lot of stuff for you. It builds, it does your doc. It's got, you can do bug reports with it. You can run Go tool fixes, basically from one version to another. If they had a breaking change, they usually offer you a fix. You can generate Go files. You can get other Go files. You can install Go files. I mean, as you can see, the list goes on and on. And this is basically the Go tool, and you use this in and out all day long. So the Go tool is basically where things are at. And you can see it's like the Swiss Army knife. And you'll get pretty familiar with all this. Now, I don't use all of these tools all the time, but I use a vast majority of them in my daily work effort. So you're definitely want to spend some time with this and get to understand what all these actually do. So this is basically the Hello Go, right? So everybody's got to have your Hello Go. And if you're following along in the examples, you can actually see really quickly, there's a download source code right here. So download source will actually download all of the source code for this entire chapter, Go at a glance. And it will download to your local directory and you can run it. Otherwise, you actually have this little play button right here too. This play button will actually drop you out to the playground that we talked about earlier. And you can actually run this from the playground at that point. You see at the bottom here, it actually says Hello Go. So this is a great way to actually see some of these code examples run. Again, you can run them locally by downloading the source, or you can go ahead and just press the play button. Not all things will run in the playground, but most of them will. So here is a really simple NetHTTP package that provides an HTTP server. So this code right here, you won't want to run it on the playground because you won't be able to connect to it. But if I ran this locally, you would actually see that this is going to start up a web server. So basically, pretty simple set of code right here. It's going to have a handler that just says hello web. We're going to start the server, we're going to listen to it, and then we're going to check the error. And basically, this is just going to set up a really simple web server. It's not really useful for anything other than just demonstrating that in a few lines of code, I can bring up this web server, okay? What's really important to understand about this is a very high-performance DOS hard and production-ready web server, okay? It actually serves sites like dl.google.com, which is where all your app downloads come from, and so on and so forth. So this is not, just like, hey, people ask me all the time, can I use this in production? Yes, this is definitely a web server you can use right in production. It's the same web server that everybody else is using from Go. Nobody has created their own little web server. So this thing is really, really durable. It's just a fantastic, highly performant web server. So definitely don't feel shy at all to use this in production. So if you haven't done your first Go program yet, it's definitely time to do that. So I would grab your favorite editor. I would literally cut and paste this real quickly. And I would put this in a file locally, and you can just call it hello.go. So basically, grab this code right here, create a file called hello.go. And then to run that, all you have to do is say go run hello go. And you should be able to see this actually do the hello world message when you're done. So if everything's working properly, this will be your very first Go program, very straightforward, very simple, and it will print out hello world. This is actually taken directly from the Go install, so this should work for everyone. Very straightforward. Again, if I just run to the playground and do this, nothing too shocking here. It prints hello Go. We're going to talk about command line programming in Go real quick. And I know we're covering a lot of material here, so we'll slow down here now a little bit. But let's get into command line programming. So Go basically allows you to quickly and easily create a command line program. So in this example, we're basically going to cover the basic concepts of command line arguments using the flags package. And again, I linked the flags package here. So if you want to go ahead and look at documentation for anything, there's the Golang actually has really, really good documentation on all of their libraries. So that is something that's pretty nice. So basically in our first CLI program, we're basically going to create a file called cli.go. So go ahead and open up your editor and create a file called cli.go. And this is the contents that we're going to put into it. So basically we're just going to go ahead and put in this func main. And so if you haven't done a Go program before, every program is going to have a main as an entry point if it's actually an executable. And it's going to have this func called main. It's going to take no arguments, and it's going to return no arguments. And all we're doing here is we're just creating a var called cmd. It's a string. And here we're using the flag package, and we're going to define a string var. We're giving it the pointer to cmd right here. And don't worry about some of this stuff if you don't understand the nuances of pointers and so on and so forth. We're just kind of explaining how some of these work, and we'll go in more depth on some of this in a later project as well. Then we call flag.parse. And flag.parse basically is going to bind this variable to the arguments that came in to the command line. And then we can just run a basic switch later basically saying, and this is just to show that the CLI actually works, and we're going to say if we sent in hello as the command, we're going to print the hello out, and if you sent in buy as the command, we're going to print out buy. And if you don't send anything, we're actually going to print the flag.usage. Now, what's really cool here is we get this for free. So flag.usage actually knows what to print out without us doing anything because of the way that we actually bound these flags in here. And so we'll show an example of that here as well. If I go ahead and open up my browser or my editor, so you can see I've got the basic program here, and you can see that's what I'm running. So if I run go run basic.go and I don't pass anything in, it's going to actually give me the actual usage right there. So see how it's telling me that, hey, you have to pass in this parameter called cmd, it's a string, and then the help actually says it can be either hello or bye. So now what I can do, if I actually want to make this work, I can pass in cmd and I can say hello, right? So if I do that, now I get hello as you would expect, and if I type in bye, I would also get bye. Now what's really nice, if I go ahead and type in an argument called foo and I pass anything to it, it's actually going to tell me, hey, you provided a flag that's not defined called foo, and then it prints out the usage for me again. So this is actually really cool and pretty powerful. So by just using the flags package like that, it's pretty straightforward, and it actually gets me quite a bit of power out of that. So I really do enjoy the fact that that works just that simply. So to run the program, we just covered that. So you can go run cli.go. Mine actually, I think I called it basic.go, so I should probably update that to be cli.go. And then you're going to get something like this, right? Now you're going to see, because you did go run, that you've got this really big string right here. It's got all these temporary files and all this kind of stuff. And because basically when you do go run, it's going to create a temporary binary and run that for you. And that's how you kind of get away with that. And that's why you're getting this really crazy string like that. And we just kind of already covered how to pass the arguments in. So that should be pretty straightforward. And then, so in this case, we actually use the string var, and that was how we bound command, the CMD variable. So if you look at the string var, you can see all the help on it. Again, so I linked all that out there. But again, pretty straightforward for what we're doing today. But what if we actually want to actually build the binary, right? We can actually do that too. So right now, this go run gives you this really crazy command. But if I actually want to build this, I can just go build. And there we go. And that actually builds it. And I can prove that. I'll remove the basic. So you can see it's not there. I'll actually remove the exe as well. That's there. So now you can see there's no executable there whatsoever. I'll go ahead and build that, and voila, I have that. And now if I run this right there, you can see that is the actual command. So pretty straightforward at that point if you actually want to build your own binary. Cross-compiling is actually pretty easy too. So you saw I actually had an exe there, which is actually for Windows. And we can do that by setting these two environments, which we found out from Rob Pike are actually called Goose and Gorch. So if you're asked what these variables are, they're actually pronounced Goose and Gorch. And the Goose is basically the operating system, and the Gorch is the architecture that you're targeting. So if I go ahead and I copy this right here, and I tell it that I want to target Windows AMD 64, and I want to build this file, voila, I have an executable that I can now run on Windows, or a Windows binary. I can put this on a key fob real quick, walk over to a Windows machine, put it on there, and this will actually run. So that is how easy it is to actually cross-compile things. So if you're writing any command line programming and you need to have it cross-compiled for different platforms, this is one of the reasons you're really going to want to use Go, as you can imagine. So if you're looking for all the different environment variables in Go, here they all are out there. Mostly you're going to be looking for your Goose and your Gorch. So here are all your possibilities. So if you're trying to figure out where to compile or what your target is, here's all the options that are currently supported. Keep in mind that not everything works 100%, but the majority of the mainstream ones do. So you may have different mileage depending on where you're trying to compile to. So that's basically a real quick dip into command line programming. Obviously, from there you can do a lot more, but this gives you kind of the basics on how to bind some arguments, how to interrogate those arguments, and how to print out some usage. So pretty straightforward, very simple stuff there. So concurrency, this is the one thing I think a lot of people come to Go for because they hear all kinds of cool things about it. And it is pretty cool, and I do feel like Go did a really good job with concurrency. Mostly from a readability and understandable standpoint. They make writing concurrent programs really enjoyable and not that confusing. So that's a really big bonus for Go. We're going to basically cover the basics of working concurrently. We're not going to cover anything super in-depth. We're just going to cover some basic concepts. There's a great talk by Rob Pike on YouTube, which is Concurrency Is Not Parallelism. And so I highly recommend that if you haven't seen this talk or you're kind of confused about what concurrency is versus parallelism, this is really simple. It's not really technical. It's really kind of just a layout of like what this is. So it's a really nice overview. But in a nutshell, what you'll really get out of it is that concurrency is about dealing with a lot of things at one time versus parallelism is doing a lot of things at one time. And Rob does a really good job of explaining that. So take a chance and watch that video. I think you'll really enjoy it. And it's just actually kind of fun and enjoyable. So basically, sometimes when you do a lot of operations that are going to take an unknown length of time, right? And to do this as fast and efficiently as possible, we want to use Go's built-in concurrency to leverage modern CPU architecture and really use all of our cores up and really get things zooming as fast as we can. So let's take a basic problem. And to keep things simple, let's pretend we just have a list of websites and we want to monitor response times, right? So very simply, we want to go ahead and take a list of sites. We're going to pass them through this program, and we're going to see what the response times are. So we're going to start with a basic command line program, and this doesn't really do anything concurrent, but I just want to show you that we talked about flag package earlier, but if we do flags.parse, and we don't actually have any flags, we actually do get a flags.args, which is pretty important, and what you'll see when we do that, you're going to see this kind of thing. So let me get out there real quick. So if I do go run, monitor.go, you're going to actually see, let's just clear the screen here so it's easier. You're going to see that it just gives me a couple of empty brackets. And it gives me that because basically it's telling me the args was empty. So if I pass in some arguments here, and let's go ahead, some recognizable names, you can see that now what you've got up there, they actually send out this array or this slice in Go of google.com, yahoo.com, and microsoft.com. Those are the actual arguments that got passed in by the command line, as you can see here. So all we're illustrating here real quickly is we just want to take a list of things in, right? So nothing too shocking, but I just wanted to make sure we understood that before we moved forward. But now we actually want to retrieve and record the response times, okay? And so in order to do that, we're going to have a couple sections here. So the first thing we're going to do is we're going to have the function main. We already saw this where we basically do flags.parse, but now this time we want to capture those arguments, right? So we're going to set flag.args to this variable called sites. We're going to go ahead and keep track of the start time. So we're going to say time.now, and we're going to track that. I'm going to call a function called process sites that takes a slice of sites as an argument. And then I'm going to go ahead and print out how long the entire process took, okay? And so if we look at this process sites method or function, pretty straightforward, it takes this slice of string. It's just going to go ahead and loop through all of the sites. I'm going to start, and I'm going to track the begin time for that. I'm going to actually just retrieve the site and go. It's as simple as just http.get, and I pass it the URL. If I get an error, I'm going to print out what the error was, and I'm just going to continue because I want to process all the sites. At the very end, I'm going to print out, I retrieved this site, here's the status code, here's how long it took. If I want to run that code, I can go ahead and modify the code accordingly, and I've already done so here, and I put it in this monitor 1 program. So if I run this now, you're going to see that it's going ahead and it retrieved Google. It took about 482 milliseconds. Yahoo took about 557 milliseconds, and Microsoft took a whopping 1.4 seconds. They all returned with the status code of 200, and the entire process took about 2.4 seconds. So now this doesn't seem too bad on the surface, right? This is something I could probably run any day, and I'm not really going to worry about it too much. However, imagine if this was at scale, right? Imagine if I had 10,000 sites or 100,000 sites or 1 million sites that I had to monitor every 5 minutes or every 10 minutes or something like that. This would obviously not scale properly, right? This is going to take me forever to run because everything's going to be serial and nothing's doing concurrent programming at this point. And so now what I want to do is I actually want to take this program and I want to make it concurrent. And we want to try to speed this up and make it a little bit better. At this point, what we have to do is we're going to make a few changes to the actual main. And so pretty much everything stays the same as it did before. I'm going to introduce what we call a wait group at this point. So wait group is basically just a counter. I always tell people to think about it as something that's going to increment and it's going to decrement. So it's not really difficult to understand the concept. And people always ask me all the time, if it's just a counter, why don't I create my own counter? The reason why is because of race conditions. And if you're not familiar with race conditions, it's basically the fact that you have 2 different processes reading and writing from the same memory location. And that will create an unknown output, right? You have a potential for an outcome there that isn't predictable. And so you don't want to do that. So you don't want to have a race condition. And so the sync.wait group is basically, it's concurrent safe. It already understands how to deal with wait groups or how to deal with concurrency. So it's not going to read and write from the same memory space from 2 different processes. So that's why we use a wait group. Again, we're just going to get the start time, and we're just going to add the length of the sites to the wait group. And all we're doing at this point is we're basically saying, listen, how many of our sites I sent in, I need to decrement that many times. We'll see what that means later. But we basically add to the wait group how many things we're going to process, and then I call process sites, and I pass it a reference to the wait group. I'm passing a pointer here. And then I just basically call wg.wait. And what wg.wait does, it waits to see everything that is actually finished in that wait group. And we'll show you in the next process how it does that. But effectively, that's what's going to block the program. If I did not have this wait here, you would actually see the process actually exit before all the Go routines ran. And so it's very important to understand that we have to wait for all of these to run first. So now into my process sites, you'll see the signature for the function changed a little bit. I'm taking that actual pointer to a sync.wait group at this point. The for loop looks pretty much the same. Now I added this anonymous func here. This is what in Go we call an anonymous func. And it takes an index and a site. And right here we have this really handy dandy little thing called defer, and we call waitgroup.done. Now waitgroup.done is just a decrementer. And so remember I told you that a wait group is just a counter. You're going to add a bunch of things to it, then you're going to decrement everything down. So if I added 3 things to the wait group in the previous main routine, that means I have to decrement wait group 3 times before the wait's actually going to stop firing. So when this defer.wait group actually gets down to 0, then this right here, this wg.wait from the previous screen, that's actually going to stop blocking at that point. So that's what the actual wait group does. It's just a decrementer. And so the thing about defer, what defer does is defer basically says, I'm going to run this when I exit the scope of the function it was defined in. So when I exit this function right here, this scope, that's when defer is actually going to run. So defer is just a keyword in Go. It's really handy. And what's nice is I can basically put this here, and I don't have to worry anywhere else where I'm going to exit scope to go ahead and decrement that done. It just means anytime I exit scope, it will go ahead and decrement that for me. And that makes my life really easy. So we use defer quite a bit in Go for things like that. So again, the same type of song and dance that I had before. I track my begin time. I go ahead and retrieve the site. If I have an error, I print this error out. Otherwise, I go ahead and I print out that what happened. Now, notice that this anonymous func right here actually has a closure at the end. I'm actually sending in this integer in the site. I already have reference to it up here just from being in scope here. But if I don't create this closure right here, you're going to find out that it's actually going to have the wrong data by the time it actually runs. So this is a really common bug when people get into concurrent programming the first time, is they don't create a closure around these variables when they pass into this anonymous func. And then what happens when it actually gets time to run on the scheduler, it's already pointing at the data that you didn't expect it to. And I can show you an example of what that means later. But just understand you really got to scope these properly or you're going to see some really odd results, and we'll talk about that. So now we can go ahead and run this. And so if I run this now, and I already have this set up, is my monitor 2 program, and I run that, you will see they actually didn't return in the same order now anymore, right? You'll actually see that Yahoo ran first, came back, and that Google ran second, and it took 672 milliseconds. Microsoft now took a whopping 2.28 milliseconds. But the really important part here is you can see the entire process took 2.28 seconds, which is about as long as the longest one to run. So at this point, this entire program can basically complete in the time that it takes the longest one to run, because they're all concurrent at this point. Now, obviously, you're constrained by system resources and so on and so forth. But you can see now this is much more scalable. So this is a really important concept in concurrency. This really allowed us to scale up pretty quickly. And you can see how much faster this actually ran at this point. If you got any questions on that, let me know. But that's basically what you can see is we took a very simple program that was this one right here, right? It didn't take much to change this. We added a wait group on this part. We added that wait group in here with a anonymous go func in this code, and that's all it took. So 4 or 5 lines of code, we took a standard program and made it concurrent. So it doesn't take a lot to make a concurrent program in Go, and it's very, very powerful. So a lot of people think of concurrency and the need for it to be really advanced concepts. You can actually use it really, really simply and really, really powerfully. So I definitely recommend learning definitely how to use some of these concepts for some of your local stuff. And I actually did run this against 100 sites real quick, and you can see the results. And so you can basically see all these things, and you've got a few that time out, but 51 seconds to run 100 sites, but basically you just got some that pretty much timed out. So we would just probably remove some of these in the future so they don't time out, they'd run a lot faster. But yeah, you can see that that actually runs at scale, the exact same code that I have there. So congratulations if you actually followed along and actually did this locally. You actually just wrote your very first concurrent program. So next we're going to get into net HTTP. So in this example, what we're going to basically cover some real basic things. We're actually going to spin up a web server. We're going to cover some basic routing, and we're actually going to get into some website templating with Go. I will say straight out that templating in Go isn't as powerful as you'd probably experienced in other languages, but it has gotten a lot better from what it was, and we will cover some of that and show you how all of that magic works. So let's get into our very first program here. So we're going to create a very, very, very simple webserver.go file, and basically all it's going to have the func main in there again. This is the first time you're going to see this handle func. It's got kind of a unique signature, and we're just telling you we want to handle just the slash. And you actually pass it a func. That's actually one of the arguments. So a function in Go is a primitive as well, just like anything else is. So you can actually just use them as arguments, just like a integer or a string. And this is going to take a response writer and a request. And all we're going to do is we're going to just do a file printf, which is fprintf, out to w, which is the response writer. And we're just going to print hello world from %q, and we're just going to take the path from the actual URL. And then all we're going to do is we're going to log.print, starting up the server on this right here, because we told it this is where we want to start. And then we're going to log.fatal, and all log.fatal does is it just checks the return of this right here. And just so you understand, listen and serve is actually a blocking operation. You wouldn't normally do this in production, but just for purposes of this example, this is what we're going to do here. So let's go ahead and fire that up and actually see what happens. So if I go run webserver.go, it tells me it started on localhost 8080, right? So how do I know that's actually running? So let's go ahead and test that. And it says hello world from there. Now, just so you know, I'm not pulling your leg here. This actually does work, and I can go ahead and say that. I can say anything I want, right? So I can say bar, foo, bin, baz, do anything I want, right? And you can see that that's actually going to respond to everything I have right there. So that's a pretty straightforward way to run that. And you can basically go to everything, right? So that's our very first web server. So you can see how quickly and easily it is to bring up some basics and actually serve some web content. But it's not very useful yet, right? And notice that it'll actually respond to any route I give it. So that's not very ideal. So in the real world, you would not want that thing just to start responding to everything, you're going to need a little bit more control over that. So we're going to go ahead and we're going to add some routing into that. One of the routers that I've used almost since the beginning of my time with Go is the Gorilla Mux router. It's really simple. There are a ton of routers out there to choose from. If you decide you want to use a different one, just do some research. They're all fantastic at the end of the day. There's really not any horrible routers out there that I've experienced. They do have a lot of router wars out there. They try to claim like who's the fastest. In my experience when doing web development, if the speed of your routing is the issue, you have won the internet. So yes, some are faster than others, but if that is actually your bottleneck, I would be very surprised. So I typically tell people to pick the router that's just easiest to understand, especially if you're new to Go, and go ahead and use that one instead. So you'll see the big difference here is basically we're going to create a new router now. So we're using this Gorilla Mux router, and I'll show you in a minute how to get that local to your machine. But we basically are just going to say, here's my route. I'm going to set it to mux.newrouter./, and then I now have this reference, and I can say handle func. And I can say, okay, off of the slash again, I can tell it I want to handle the index function. Now, notice down here, I defined func down here of index. And so that's just a variable, basically, in the namespace at this point. And notice it's got the same signature as my anonymous function that I had earlier. So we've got kind of the same moving parts, but you can see this is quite a bit easier to read, I think. It's much more readable and much more easy to understand. This is broken apart on its own, so this is now my discrete handler. And I pretty much start up in the same way I did before, and I go ahead and I just do this and serve, but this time instead of giving it that handler I had before, I actually just give it the router, and the router knows how to respond to everything that listen and serve is going to ask for. So this is a pretty straightforward one right here, and you'll see that we can pretty much run it the same way, but now I just talked about this is the first time we're using an external package too. So if you look back at the import, before then all the imports were from our system packages, and so Go knows how to use those pretty quickly, but if you use something that's an external library, this was not going to be on your machine yet, right? Like all of the code in the world is not on your machine. So we actually have to do something different to get this. And it's actually called go get. So go get is a command from the tool chain we talked about earlier today. And you're just going to say go get github.com gorilla/mux. And this will actually bring the code local to your machine. And that will allow you to use it in your project and compile it. So this is pretty cool. So they make it pretty easy to actually go ahead and grab that code. So if you haven't used Gorilla Mux before and you're running this example, you will have to run this at the command line to bring this code locally. So now if I go ahead and run this, so I'm going to kill this off and I'm going to run the next one. So this is now using the router. And if I come over to here and I do this, you get the same thing, right? Okay, so you're probably asking me what really changed here. I just went through and did all this stuff. I went through all the work of doing this, but I didn't gain anything. Well, actually we did. Because look at that. So now if I do /foo, it's going to give me a 404 page not found. So this is how I start to control my routing, right? So at this point, I'm not going to respond to everything anymore. I'm only going to respond to the routes that I've defined, which is how you want a good, well-behaved web server to work. So very simple to go ahead and get that working like that. But now we need to make a basic template, right? Because this is pretty useless right here. I mean, yes, maybe you need to write an API that simply responds to text, but I find that's pretty unlikely today. So let's go ahead and actually talk about the HTTP template package. I do have the link here, so if you need to learn more about templating, there's all kinds of stuff in here. It does quite a bit of stuff, and we're just going to cover some really basic things today just to show you how to get a basic template running. Again, not much has changed with the main. So if we look at the main function, pretty much the same thing that we had before. But now the index is going to be a little bit different this time, okay? So the index is going to be a little more complicated. So the first thing we're going to do is we're going to fill out the page data for the index, and we're going to create this struct right here, okay? And we're just going to create a struct called page data. We're going to give it a title and a body, and I'll show you where that struct is actually defined later, so don't get too caught up on this. But this is the data that we're going to actually pass to the rendering engine. And then I need to get a template, and so I get a template by using this little render method I created, and we'll look at that in a minute. And so if we just go ahead and get a template, if we get an error, we want to go ahead and write that out. Now notice I'm doing a little more housekeeping at this point. I'm actually using the right header, and so if I get an error, I'm going to write out the header and say, hey, I got a status bed request, and then I'm going to actually write out that error that I actually got. Now, normally, we would want to hide these types of errors from our end user, but for just what we're doing here, we're going to go ahead and use this error instead and write that out just to show people that we actually are getting an error. But if all went well, we actually can just go ahead and write out the template. There was a lot of little stuff in there, but there's a few functions we have to look at to understand what happened here. So the first thing is we had this type called page data that we defined, and we're just creating a type called page data. It's the first time you've seen a struct if you're not familiar with Go, but this is basically how we handle objects in Go. We just create a struct, and we tell it it's going to have a title, and it's going to be a string, and we tell it we want a body, and that's going to be a string. So nothing too fancy. And then we define this HTML variable as a constant, and it's just text, and we use these backticks in Go so we can do multi-line text. And this is the actual template itself. So it's HTML, it's got a title, it's got a body. And these curly brackets right here signify that I want this to be one of the variables from the data that's sent into this template when it renders. And .title is how I reference into these variables. So if you notice, page data has a title. So that .title here, and it also has a body, and it has a .body here. And that's kind of how that matches up. That's how we actually get the data structure to pass to the actual template. But now how do we bind all that together? To bind all that together, I actually created this render method. And in Go, you'll probably have a lot of helpers that do this if you're writing templates in web, and this is kind of what I've done. It just takes the page data, which is the actual struct, and it returns a string and an error. And the first thing it does is it needs to create a new template. And if you look at the library, you'll see template.new, takes a name, and then I parse the HTML. Now, HTML, again, was this constant that I created, right? So it's actually just a string of data, but it's got template information in there like title and body. And so I go ahead and parse that. If I get an error, I return just an error back. Otherwise, I need to go ahead and get that data into a buffer somewhere into bytes. And so easiest thing is just use a bytes.buffer. And then I basically do a template.execute. And when I do an execute, it's going to write the data from that rendered output into this out right here, which is a bytes.buffer. And it's going to go ahead and it's going to use the page data as the actual data object to bind that. So when we looked back here, remember we said that we got this title and this body? Well, so does this page data. And that's how it actually knows how to use a little bit of reflection behind the scenes and actually bind that data in there. And if all goes well, I can simply return out.string because bytes.buffer has a string method on it, and nil. So if all goes well, I'm going to return a string and no error. And that's how I actually get that data that's going to be bound out there. So there's my web server running again now. And now I go ahead and I request the index. Now you can see I actually have real HTML here, right? So a little bit prettier. This isn't the best page that you're ever going to see on the internet, but it's actual HTML now instead of actual text. And that's using an actual template. That is kind of the whole ball of wax when we look at that kind of stuff. I'm going to go back real quick to this real quick, and I'm going to expand this whole thing so I can kind of walk through the whole program at once. So all those pieces now kind of shown at once. This is the same program we were just talking about the whole time. But you see the imports up here. You see the page data and the constant. You see the main that really didn't change at all. And then you see the index that we talked about and the render function. Okay, so this is kind of putting it all together. If you are on your local machine or on there, you can actually download the source right here. All this source is all this code in there. So if you want to download this source, it's really easy to do that. Just click the download source, you'll have it locally, and you can actually play with this locally. And this kind of gives you the whole big picture of how to put together some basic web rendering with some basic routes and some basic templates. Now, this obviously isn't going to be a production website, but this starts to put the building blocks together for you a little bit, okay? So I've just got a question here, and somebody's saying that they're super new to Golang. They started looking a couple days ago, and they want to know if the func in all files are global. Will that clash with bigger projects? So no, they're not global by default. So everything's scoped by project, and you have basically exported and non-exported functions. And basically, if you don't want to export a function, it's lowercase. If you want to export a function, it's uppercase. But everything is always scoped by the actual package. So you see how we have in here, we imported the mux package up here, and we wanted to use this new router, which is a public or an exported method. To do that, we have to do mux.newRouter, right? So you can have new router defined in 500 different packages, but they're all going to be prefixed by mux or whatever that package is when you go to call them. So this is a really nice way to namespace everything, so you don't have to worry about clashing any function or method or constants or anything like that, types of that sort, outside of your package. So that allows you to do that pretty quickly. But if you want to learn more about web development, there are a lot of great resources out there. Actually, Mark Bates is actually with us today as well. He actually wrote the Buffalo project. So if you're looking for some really rapid development, I highly recommend going to check out the Buffalo project. It's all native Go. And it's the closest thing to rapid Rails development you're going to get without the headache or restrictions of using a framework. So Buffalo is not a framework. It's actually an ecosystem. It's a really important distinction. It is a fantastic tool. It's got migrations for databases. It has database support, templating, generation, scaffolding. It's just super cool. I highly recommend that if you're going to start getting like any production type, scalable type websites, definitely check out Buffalo. If you decide that you want to hand roll everything, which I don't recommend, but if you decide you want to hand roll everything, you can do that too. I wrote this article, look at this, way back in 2014. So it's going to be a little bit dated, but most of the concepts in this article that I wrote are still very valid today. So go ahead and take a look at those. And then you will go ahead and see how to, if you want to make a JSON API in Go, it's actually pretty simple. But again, you're going to handle a lot of this stuff. It's pretty bare metal. I highly recommend looking at some other frameworks instead. And then building websites in Go is actually a Git book, so it's actually a lot more as well. So again, this is another really nice book if you're interested in learning more about that as well. A lot of information out there. If you're looking for more information on Go, there's just great information out there. Golang.org is really fantastic starting place for the actual Go project itself. Has all the documentation out there, a lot of getting started guides, a lot of language tours, the whole works. Godoc.org has literally all the Godocs for every published package out there. It is an amazing resource. If you're ever wondering, oh, I wonder if there's a package for, I don't know, images, right? Go ahead and search all the packages out there, and you get all the image support out there and all the different ones out there. There's typically, something for any, QR code. Like, I don't know, I need something on QR codes today, right? Look, here's a bunch of packages on QR codes. What's really cool about it is I can click into it, and here's all my documentation, right? So this is fantastic. This one even comes with some examples. Here's how to use the code. So definitely take a look at the GoDoc site if you're new to Go and you're looking for things. It's fantastic. Gophers Slack already. I'm hoping that everybody's on there. I saw a few people join while we were doing this. But I definitely hope that everybody gets on Gophers Slack. It is the place to ask questions. It's where Mark and I are all the time as well. And just tons of other very, very helpful Gophers. The one thing I can tell you about Gophers Slack is you are very welcome to be there. If you ask a new question or something relatively simple, people are not going to get mad at you and they're not going to get upset. They're actually going to help you and put you in the right direction of where to get help for those types of questions. So please join the Gopher community. It's very welcoming. We really don't put up with any people being mean or rude out there. We do patrol it pretty heavily, and it's very welcoming, so definitely check that out. And this is the invite for that as well, but you should have already done that, so hopefully you're on that already. There's some really great books out there, the Go programming language. There's actually some really great videos out there from Riley. But some of my best video series by far are the Just for Funk from Francis Campoy. This is just fantastic. You have got to check out his stuff. They are unbelievable. And so I definitely recommend checking these out. Every one of these I still watch. I learn something every single time I watch him. He's just fantastic at presenting. He just has fantastic ideas. He's on the Go Core team, obviously. But this is a video series right now that if you're not listening to, you should definitely be listening to. One I actually don't have here that I should have out here is GoTime.fm. GoTime FM is actually another podcast by Eric St. Martin, Carlissio Pinto, and Brian Kettleson. These podcasts are fantastic. I definitely recommend getting out there and listening to these as well. So another great resource if you're looking for something to listen to. And then finally, I do work for Gopher Guides, and so I do customized in-person and virtual training. We're actually be offering self-paced training from our system here on the Learn platform shortly as well. So it's one of those things where we'll probably email everybody and let you know when that's coming up. But if you need any training or virtual training, go ahead and don't hesitate to reach out to us. And lastly, I'm Corey the New. I noticed that the markdown table doesn't render properly, but we'll get that fixed Sunday. But if you need to get a hold of me, I'm on GitHub, also on Twitter and on LinkedIn, or you can email me. So don't hesitate to reach out at any point. I'm also on Slack at Corey the New on the Gopher Slack. I typically will answer. I always tell people to try to ask me questions in public channels so that everybody can share from the answer. But don't hesitate to go ahead and reach out to me directly. So that's the end of the presentation. I will go ahead and stick around for about another 5-10 minutes if anybody's got any questions. So don't hesitate to ask any questions and follow up. But again, if you need to reach me after this is over, you can reach me at any of these different areas here. So again, thanks everybody for coming. And I hope that this was helpful to everybody. And hopefully we will see you at some of our future ones.
This video was brought to you by Gopher Guides. If you're an organization, conference, or user group that is looking for Go training, please visit gopherguides.com. All training is custom designed to match your educational needs.